Now the beginning is, early sort of 50s, 60s type thing, not from the dawn of mankind. A lot of road research was being undertaken by individual road authorities. And so the problem with that was that, whenever there was a heavy demand on everyday work, the research was set aside. The research couldn't be relied upon from other countries because we have specific conditions in Australia that aren't applicable to some of the research. Basically there was a resolution established where it was clear that there needed to be some sort of organisation to provide for the research need of the Australian road authorities. And this is, so I've been around roughly for around about 50 odd years. So yes, that just gives everyone a bit of a brief background from ARRB. The history is a lot more interesting than that, and there is a book out, 50 Years of ARRB, if anyone's interested. All right, so let's get started. So we're going to start off with looking at the Austroads laboratory research, and what we have here is we have all the research programs that we do under Austroads, and Austroads stands for the Association of Australasian Road Transport and Traffic Agency. And their main aim is to provide expert technical input to national road and transport policy development, improve practices and capability of road agencies, and promoting operational consistency by road agencies. I've also got a web link there if anybody's interested in finding out some more information. And so what we're going to be focusing on today is pavement technology. So that's the research program that does utilises the laboratory the most.
Fantastic. Well, from what I understand, we want to learn a little bit more about our audience today. So we invite everyone to participate in a poll. Now, momentarily, you will see a box appear on your screen with your questions there, and if everyone could just submit their answer choice, we'll tally those at our end and see how we go. So we just want to know a little bit about who your employer is. Shannon, do you suspect one answer choice will be more popular here than others?
Yeah, I've got a bit of suspicion that maybe the other part of it might be the one of the major ones, although I wouldn't be surprised if the state territory road agency one would be one of the ones that was the most popular.
Fair enough. Well, thank you everyone for getting your votes in. I will close and share those results. So we suspected correctly, Shannon, we have 59% of our audience is from state territory road agency, and the next highest is consultant or contractor at 27%. So
lovely.
Lovely?
Lovely.
Alrighty.
All right, so let's get stuck into the research. Now, basically, these are the 4 research programs that I'm going to be discussing very briefly today. I don't have the time to go into a lot of detail in relation to specific outcomes and the processes that went into establishing all these various projects. I've picked these 4 specifically because they highlight some of the specialty items of equipment that we have here at ARRB that we use extensively for our research programs and also for consulting when there is a need. Okay, so the first research project we're going to look at is the long-term ageing test methods for spray sealing binders. So in Australia there's an established method that is a little bit outdated, uses outdated equipment, and there aren't many people that have the capacity to be able to do that testing. So this is probably the 3rd or the 4th year in the long-term project for this to develop a new test method. And one aspect of this project was with the developing a pressure aging vessel, a PAV/dynamic shear rheometer bitumen durability test method. And and for that we assessed 11 field trial binders where we have actual performance out on the field. So one of the instruments that we'd like to discuss here is the dynamic shear rheometer. So what you can see there on the left-hand side of your screen is our dynamic shear rheometer with the Peltier plate heating apparatus, and on the right-hand side there you can see a twisted binder sample, one of the ones that we've put through the aging process and testing. And so basically what we did for this project was we aged the binder at two different aging conditions to try and simulate the changes in potential properties out in the field. Now obviously that's why we chose the field binders for this one, because we can go back to the job sites and match with our theoretical estimations of the potential aging properties and cracking with actual field trials. And so the summary out of this was we used an ASTM method was the basis for this, for the DSR test method. We have developed a new DSR test method that is currently going through the Austroads approval process at the moment, that will be specific for Australia and is based around quite a sound amount of experimentation here at the lab.
And Shannon, how long does it typically take to run a DSR test?
It's a good question, Angela. Depends on the type of testing that we're doing. For this particular project, a standard test would take roughly 2 hours before we got a result. Contact time is, preparing the sample, things like that's roughly only got half an hour, 40 minutes. But you can vary that significantly. We can do different strains, frequencies, and temperatures depending on what's required and what information we want to get out of it. So yeah, so that's that one. And we basically, in summary to that project, we found that all binders demonstrated certain property changes generally in proportion to the increased aging time. So that was a good little bit of investigation there. The second project I'd like to talk about is characteristics and performance evaluation of granular bases. This is a long-running project that you can see there that maximises the use of available material in road-based construction, reduce road agency costs. I won't read all of that, but basically what we've done early on is we've developed, in partnership with Austroads, we've developed a new piece of equipment that at the time was a prototype for Australia, and that enables us to test large samples of material. I'll get into a little bit more details in a minute. And for this particular project, we looked at 4 different unbound materials. So you can see here, this is a picture on the left-hand side of the Austrac. So what we can do here is we can compact and track pavement samples. At the moment we're doing unbound pavement materials. The sample size that we're producing is, the weight's roughly around about between 200 and 300 kilos, and the sample's around about 300 millimetres deep. So we do the compaction part of it. What you can see in that picture, it's in the tracking mode, and on the right hand side there you can see a laser profile of the rutting of the particular sample that we tested. So that's it's a pretty fancy bit of gear that uses a laser profiler to establish the initial surface, and then we measure the rut depth at various different locations and times. And this project, when we compared this with the results that we've got for this project to previous repeat load triaxial permanent deformation data, including moisture sensitivity analysis, the wheel tracker provided a better way of identifying potential severe early shear failures for some crushed rock, more sensitive to moisture. Okay, so before I move on to the next to the next research projects. Does anyone have any particular questions for those first two that we've discussed?
Yes, ladies and gentlemen, as we sort of said at the beginning, webinars are more enjoyable when they're interactive, so please don't hesitate to get your questions through for Shannon, and we'll answer those as we go. Shannon, I imagine with a lot of this equipment that you've showed us so far, and some of the ones you're going to show us throughout the presentation, there are obviously safety implications. How do we make sure that our people in the labs are safe when they're using this kind of equipment?
Yep. So that's another very good question. So we've got standard safe work method statements that that need to be completed prior to any work being undertaken. For the most part, some of the equipment that we have that we buy off the shelf isn't up to an appropriate safety standard, so we may need to put things like guarding interlocks, things like that. So yeah, we need, and especially for the one that I've just been talking about, the Austrac, because we've got up to 300 kilos worth of material. There's a lot of manual handling involved in that task. So we've got a lot of lifting devices and aids to assist us with the processing of the sheer volume of material that we need for this.
Fantastic. And just a reminder to all of our audience out there that we are recording today's session, so no need to take notes frantically. You'll be able to review the presentation material and the recording at a later time if you wish. All right, Shannon, we might move on to the next stage of the presentation.
Thanks, Angela. So the next project I'd like to discuss in brief is binder characterization properties of for enhanced performance. Now, this is looking at the effect of polymer-modified bitumen degradation on field performance. Do changes in the polymer-modified bitumen test properties observed over prolonged heating or PMB degradation affect the performance on roads? This was basically everybody that we've spoken to about this project had some sort of opinion on what they thought would actually happen. So this was really just an assessment of, whether or not people's assumptions were correct, and it was quite a useful piece of research. And for that, we did two types of polymer modified bitumens containing high and low polymer contents. Now, for this project, obviously it was because we wanted to have a particular type of polymer modified binder that couldn't be supplied to us. We needed roughly, for the bitumen testing and asphalt testing, we need roughly between 16 to 20 kilos worth of each bitumen. And the particular type of polymer we had to manufacture ourselves because we needed to know what we put into it. Now, obviously, we couldn't get a commercial polymer modified binder because there's confidentiality issues in relation to what goes into manufacturing of those polymer modified bitumens. So we made them ourselves. So what you can see there on the left-hand side is a heating block. That's a picture of our 1 litre heating block. We do have a 1 and a 4 litre heating block. Now what we do is we put our bitumen in that heating block and heated it under carbon dioxide and stirred it with the stirrer in the middle picture there. Now that's a Silverstone duplex head assembly mixer. It's a pretty fancy name, but basically it's one of the most efficient laboratory blenders on the market to enable us to have effective blending down of the polymer modified for the polymer going into the polymer modified bitumen. And the challenge with when we're making bitumens is to how do we know when the polymer has been completely broken down into that polymer, into that bitumen. Now that if we were to do a testing with conventional tests, we could potentially be waiting up to an hour before we know whether or not that polymer is completely broken down. So what we've got there on the right-hand side is a cone and plate viscometer, and this is out of the UK, And basically what it does, it enables us to ascertain the viscosity of the bitumen within a couple of seconds. And so when we reach a point where the viscosity plateaus, then we know that we've got the blending down. So we stop the blending process and then we create it from, then do the bitumen testing from there.
Great. Well, I do have a question for you, Shannon. How much bitumen can be blended at any one time? Okay,
so in the 1 litre heating block, we can blend up to around about 800 grams effectively. For the 4 litre, we can blend up around about 3.8 litres of bitumen. So obviously the process that, because we needed between 16 and 20 odd kilos of bitumen, we had to do quite a few blends, but we had a splitting process where we made sure that the binder was completely homogenised and test for critical properties throughout the process.
Great. And we do have a question here from George. You mind if I shoot that through to you, Shannon?
Yes, sure.
George is asking, has there been field and lab correlations for rutting of crushed rock-based material? Now, that was in response to earlier on.
Yeah, it's a good question there, George. At the moment, I don't believe there is anything that can correlate field with lab. We do have a accelerated load facility, which is the full-scale operation. But what we're doing with that project is we're bridging the gap between field performance and laboratory testing. I'd also like to mention that we have been doing some work with that, some consulting for some of our state road authorities in relation to testing some materials to ascertain whether or not they perform under laboratory conditions, and as a way of doing a correlation. So that's in the very early stages, but everything that we're seeing so far is encouraging.
That's a great question, George, and thank you for asking it. And no doubt Shannon will welcome you to contact him after the webinar if you want to discuss that in any more detail.
Yeah, absolutely. Okay, so another aspect of this was because we were degrading the binder by heating after we blended it, we wanted to do a little bit of an assessment on, we did 2 assessments. The one that we did here in my laboratory here was we took a FTIR, which is Fourier Transform Infrared Spectrometer, and that's, you can see there in your left picture. And what we did was we did an analysis of each of the polymers, each of the polymer modified binders over the various stages of degradation to see whether or not we could see any change in the spectrum that we had there. Now, obviously, I haven't included an example of one of those degradations because the graph would be a little bit messy. But through that, we were able to ascertain that we were seeing some sort of change in the spectrum. We also part of this, which we through utilising Melbourne University, we did some gel permeation chromatography. And that's basically where the chemical components separated out based on the size when dissolved in a particular solvent. So we were able to get some quite useful information out of that. I won't get into the exact details of all of that right now because it's quite complicated. But I would encourage anyone to contact me if they want any further information. And as well as that all of these that you're seeing today, they will eventually be Austroads reports available on the Austroads website for everybody to see. But yes, that's pretty much that one. Now, what we found as a result, and we did 2 lots of asphalt testing, fatigue and wheel tracking, and I'll discuss the fatigue now. So with the high polymer modified binder content, we found that through heating there was around about a 10 times increase in the fatigue performance, and for the low polymer content we found that there was roughly around about there was about 5 times increase. So so that's something that's a bit of interesting research and results that we've got as a result of doing that testing. Okay, so the last one I'd like to discuss is high modulus asphalt technology transfer to Australia. I won't embarrass myself by trying to pronounce the French wording for what AME stands for, which you can see just there. But basically, this is a new type of technology to Australia, and it's important for us to establish performance-based design guidelines for EME mixers. And that was basically what we did was we took a established EME from France. We had the materials delivered to us here in Victoria and did the comparative asphalt testing and bitumen testing under Australian conditions with some variations throughout the way.
And if we do have any native French speakers among us, we're more than happy to unmute you so you can pronounce that for us correctly if you like.
Okay, so one of the some of the testing that we did for this project was we did some gyratory compaction using the servo pack at various different cycles to determine workability. And we did that at 150 millimetre diameter, which you can see there on the left-hand side. Then what we did was we did an evaluation of its rutting, which is basically just deformation, similar to what I've discussed previously, but much lower scale. We're basically masses we're looking around about between 15 and 20 kilos worth of material. And the main variation to the EME we were tracking compared to what we would do standard in Australia is the test usually runs for around about 10,000 cycles or 4 hours. For the EME, it was important to do it at 4 hours. At 60,000 cycles, which is 24 hours. So that test was running for quite a long period of time.
And Shannon, we've received a question here from Craig. Craig's asking, can you use the same test methods that the French use for EME? I'm
sure that you can, Craig. I think the challenging part with this one is that we needed to test the EME under Australian conditions using the test methods that we already have in existence with some slight variations to those. The other part of it is that it's all about testing this new technology, not only in my laboratory here, but potentially in any laboratory there. So throughout Australia, there are a lot of laboratories that are NATA accredited for for some ASTMs, Austroads and Australian standard test methods. So there would be a process that you would be able to do that. But just as a bit of a side note, the testing that we did here under Australian conditions compared to what the French have done in their test methods, there was quite a good correlation between our results and theirs. So it just basically validated that we could take some French materials, including the bitumen, and do some testing under Australian conditions in an Australian laboratory using Australian test methods and get exactly the same results or near exactly the results of what the French could do.
Great. And just a question here from Christopher. Christopher's asking, Christopher's from Main Roads, WA, asking what are the variations to the wheel tracker test? Was it still at 60 degrees and 5% air voids? Yes, that's a very good question, Christopher. The temperature was 60 degrees, but the main part, the main thing that was different for the EME mixers is that they were actually compacted at quite a lot lower air voids than what we would typically see. So the Austroads test method for wheel tracking specifies that we need to test to 5% air voids plus or minus 1%. And what we did for the EMEs is we were around about 2 from memory, roughly 2% air voids, which so that's quite low. So that's the main variation that we did for the wheel tracker, was that the air voids that we had to target was quite a bit lower, and that matches also up with the EME technology in France as well. They're compacting to very low air voids, and that's the whole point of the EMEs, is to have less pavement but more heavily compacted to give you better performance. So hopefully that answers your question there, Christopher. So one of the other aspects of the testing that we did was we took the standard
asphalt beam fatigue testing that we do quite often in Australia, where the Australian method is one strain level, one temperature, 3 asphalt beams. The Europeans do things a little bit differently. The first thing that they do is they take 6 to 8 asphalt beams and compact, and once they're obviously compacted, we test those at 4 different temperatures, and we run a frequency sweep at about 9 different frequencies, and from that we can develop a master curve. So that's what you're seeing there in the first picture there. Then the second element to the fatigue testing is to take 18 fatigue beams. So that's quite a substantial effort in manufacturing those 18 beams, and they're split up into 3 groups. So you have six for 6 for each subset, and they're tested at 3 different strain levels. And from that, you can ascertain from that data what the flexural stiffness, when the flexural stiffness has decreased to 50% of its initial value. Now, the Australian method only uses 3 beams and 1 strain level. So the main, why are we doing all this, I can potentially hear some people asking. So the reason why we're doing this is because doing this further analysis of the fatigue brings us back to, relates a little bit more closely to what's happening in the field. And you can see there that the average air voids content of the beams using the saturated surface dry method is around about 3.1%. Standard, usually we would do 5 plus or minus 0.5. So what we've found is that by doing all of this extra testing, although quite painstaking, the value that we're getting from the information that we're producing is quite useful, and it's basically another further validation of the Australian conditions compared to the French. Now, we did have to run a different program to this one. We had to get the European programming for the fatigue apparatus because it wasn't set up for under the Australian conditions, because obviously with the different strain levels are easy, but we had different frequencies that we needed to achieve. So yeah, so that was one of the different aspects to standard testing.
And are there any plans for field trials of this new asphalt technology?
Yes, that's another good question, Angela. There is already a field trial in place in Queensland, and it's in Eagle Farm in Queensland. There was a number of we've taken some core samples from that field trial, and we're in the process of actually testing all those. But the information that they're hoping to collect and collate from the laboratory in the field will provide us a sound basis for the specification for EME in Australia. There's in the field trial we have pavement instrumentation, which includes temperature sensors in pavement at different depths, strain gauges and weather stations. We had those installed into the pavement. Data collection from this equipment, as long as with some other in situ testing like falling weight deflectometer testing, will be further validation of the process and helps us deliver to Austroads projects. I know that there is some trial happening at the moment in New South Wales, and I believe that there's going to be something happening. There's some movement in Victoria as well. So yeah, so it's something that obviously normally what happens in Austroads projects, we do all the experimentation first, and then the trials happen after that. But in this particular circumstances, it was important to run the two in parallel and to come up with some specification frameworks and not delay the technology.
Well, we do have another question here from Christopher. He's pulled a couple of great questions today. What depth are the temperature sensors?
Yeah, I'm not 100% sure about that one, Christopher. I'd have to have a look at, speak to the staff members that were involved in that trial and provide you with some extra information on that one.
Absolutely. Well, Christopher, why don't you touch base with Shannon after the webinar, and you can go through that in more detail.
Okay, so I've got some other equipment here that we use for research and consulting activities. On the left-hand side there, we've got a repeat load triaxial tester, which tests unbound and bound granular materials. In the middle there, we've got a beam fatigue apparatus that's set up for pavement materials. We've got a cement-treated beam in there at the moment. It's a similar process to the fatigue, except that we're testing granular materials, and the sample sizes are quite a lot more substantial. And on the right-hand side there, we've got a picture of our ultraviolet microscope. We've used that quite extensively in past research to ascertain the distribution of polymer within a polymer-modified bitumen. So that's not something that we get a lot of use of at the moment. Oh. Okay. All right. So now we've moved on from the research stuff, and before we get into talking about our laboratory, does anyone have any additional questions on that research that we've discussed?
Absolutely. Don't be shy, ladies and gentlemen. We welcome all of your questions and feedback and comments. And look, perhaps if something does come to mind once the webinar has concluded, please don't hesitate to get in touch. Shannon's details and, in fact, mine will be up on the in the webinar, the recording, and also the email that we send out after the webinar. So just keep an eye on that, and you can touch base with us anytime.
Okay, so as I touched on briefly there, you can see that ARRB's been carrying out quality research for over 50 years. I must admit that some of the toys that we have here are a lot more fancy than what they were 50 years ago. So a lot more efficient. For example, we did have one of the first infrared FTIRs ever bought in the country. To get an analysis from that would take up to 2 to 3 days. The IR that I showed you a picture of there, we can get an infrared spectrum from that in roughly around about 30 seconds.
Wow.
So yeah, so it's a bit of a time benefit to that one.
Just a slight time benefit.
Yeah. So so we're accredited by the National Association of Testing Authorities Australia in the areas of bitumen, asphalt, concrete, aggregates, skid resistance. All of the staff that we have working in the laboratory are degree qualified. All of them have specific experience in materials testing. We're also supported locally and interstate by locally and internationally recognised staff. And in total, all of that equates to roughly around about 150 years of combined experience, give or take 20 or 30 years, I would say. And that's a critical part to some of the work that we do here, is that the involvement from those research staff. Okay, so I was covering what for bitumen, asphalt, aggregates and skid resistance, we're accredited for Australian Standard, AUSROADS and ARRB test methods. Skid resistance, Australian Standard, British Standard and ARRB test method. Concrete, Australian Standard, AUSROADS, ASTM methods. And just to reconfirm what any people would know in the country, when you run a NATA accredited laboratory, all the equipment needs to be calibrated and checked in compliance with ISO 17025. Because I have some equipment that doesn't really fall into that NATA category, we have calibration schedules that are equivalent to NATA, and they're all internal requirements that have been assessed by NATA. Okay, so now what can we do for you? Okay, we can provide testing services to Australian Standard AUSROADS specific requirements. We can test to state and territory specification requirements.
Do you find that, sorry, before you go on, do you find that challenging that there are sort of different standards and specifications between the states and territories?
Yes, quite challenging. I think I would love that if everybody tested to the same standards, but unfortunately there's different requirements for each state dependent upon the materials are in that state. I do know that there is some discussion around potential harmonisation of some test methods. I did a desktop study just looking at NATA accreditation from our laboratory here and our State Road Authority laboratories, and there was roughly around about 1,200 odd different test methods across the group, and there was probably there was probably roughly between 40 to 60% test methods that were roughly the same, but with little inconsistencies or variations in the two. So yeah, so it is challenging, but yeah, we've got quite a lot of expertise in what's required in all the states. We can develop testing programs for you. So if you've got a product, you don't know what to do with it, we can do testing, come up with a program. We can offer complete investigation, including reporting, so that this is where we will get our experts involved in doing an analysis of the particular lab testing and basically equate that to any field performance or problems. I'd also like to state that we've done quite a lot of that recently, and we continue to have a lot of that. A lot of those types of tasks come in. The hardest part from my point of view is that the sampling of materials prior to construction isn't really happening. So, we're getting materials after there's been a problem, and it's quite often very difficult to ascertain what the exact problem is. So having those materials from inception, whether they're stored or tested, it puts everybody in a much better position to understand what's happened and where that fault lies, because there is quite a lot of things that can happen throughout the process that can impact on that final product. Okay, we can offer advice on material testing requirements, so that's whether it be a laboratory or field, and we can provide access to other laboratories, so that's the state road authorities and universities. Throughout the Austroads projects, that would not be possible if we didn't have the involvement of some of our state road authority laboratories and to an ever-increasing university laboratories. Just also like to say on the advice there, obviously the advice is free up to a point. When we get to the proposal stage, where we potentially would be proposing a particular plan to you, that's when we would you would get a small fee for that proposal, and what you decided to do with that proposal from that point onward is up to you. See, you've got access to specialised testing equipment. So I've just given you a bit of a snapshot of the majority of the testing equipment that I do have here. You've also got access to experience in new and developing test methods. The dynamic shear rheometer is a perfect example of that. That test method is, like I said, currently going through the Austroads approval process, and so there's potential that we could do testing for you before it actually gets out, before there's an established method. So you're basically getting your foot in the door in relation to potential research and testing. And we're completely independent. So whatever we don't have any materials that you send us, we can work directly with you. We can provide independent testing services. Some of our testing that we do here in the lab, our regular routine consulting, is for organisations that don't have a lab the size of ours, but need a lab the size of ours so that they can produce, asphalt or bitumen. So they're just a number of things that we do quite frequently.
And Shannon, just a question there from Christopher. Christopher's asking, does the DSR test method include a method for the PAV?
Oh, that's a good question. I'm not 100% sure with that one either, Christopher. I'd need to find out about that one as well, because we utilised pressure ageing vessel from one of our state road authorities. So I'd need to ascertain whether or not they use one of their own test methods, or whether there is. I think it's a very good idea, because the more that the pressure aging and DSR devices get used in comparison, it would be a very good idea to have a national standard, ARRB standard that could be used for everybody. So, yeah.
All right, well, we'll leave it open for a few more questions to come through. But Shannon, I guess my question to you is, if there's one message that you'd like the audience to take away from today's presentation, what would that be?
Okay, the one message that I'd really like everyone to take home is that we are doing some cutting-edge, leading research here at ARRB. That doesn't close us off to doing your own independent research. We do offer all of our research activities can be done through consulting. If you don't know what your problem is, there's a fair chance that we will be able to ascertain through use of our equipment and various different test methods what your problem could be. So we've basically got a service there that anybody can access at any time. So yeah, so don't be afraid to send us an email or give us a call, because yeah, we can definitely solve almost every problem. Not all problems, but generally we can solve or resolve almost every problem.
Well, that's certainly very reassuring to know. And a question here from Torrell. Torrell's asking, what is the approximate percentage split of work between the various sections of the lab?
Good question there. Basically, I would say as a split, the majority of the work that we're currently doing for the ARRB program is roughly probably around about 60% in the asphalt, 20% for in bitumen, and 10% for concrete, and 10% pavements. So we've got quite a lot of projects this year that are very heavy on the asphalt analysis, and that does vary from time to time. Consulting, it really depends on what particular need we have at each particular time.
Fantastic. Shannon, I want to thank you so much for sparing the time to come and deliver this webinar today. You are indeed a very busy man, so it was quite difficult to get in a time with you, but I hope our audience has enjoyed what you've presented today, and I certainly have a newfound respect for the work that you and your team do down in the labs. You're always burrowing away and we don't see much of you, but obviously that means you're extremely busy. So I hope everyone that's joined us today has now a better understanding of what we do and what we can do for you. And yeah, please don't hesitate to get in touch with us if we can be of service to you.
Yep, great. Thank you very much, Angela.
All right, thank you all, and we hope you can join us for our next webinar. And as I said, if we've missed your question or new questions come to mind, you can always contact Shannon Malone, our laboratory manager, on those contact details. And we'll also have those websites available for anyone that wants to have a look at the ARRB or AustroAD's websites. Thank you all for your time again today, and have a great afternoon. Bye-bye.